All right, it's time to go over the review questions on the mole. So we're coming up on a test really soon. So make sure that you get all the right answers on this so that you're ready for the test. Because I will grant this stuff is when chemistry gets really difficult. Because again, that mole is a really confusing concept. All right. Overall, even before we even start all this, remember that the mole is kind of like a dozen. Okay, you know that a dozen is 12. Mole is that 6.02 times 10 to the 23rd, or that 602 with a whole bunch of zeros after it. All right, that's all it is. It's just a different number for a dozen. Right, and chemists use this one. So, all right. So, first question, number 44. List 3 common ways that matter is measured. Well, 3 ways in which it can be measured is it can be measured by number, right? Which I'm going to write these up here right now while we're at it. The one that we would use for counting by number is this guy. Or 1 mole. So we have that ratio. And remember, as an equation, and on this side you have the question. Okay? So one of these would be x. One of them is going to be a number. Okay? Then we can do it by mass, where we figure out the molar mass of the substance, and that's why I have the double question mark, because it's always different depending upon what substance you're working with. This is where you have to go to the periodic table and go 1 times the mass of this plus 2 times the mass of the next element, and so on. And then the other side, this is the part that comes from the question. So one of these is an x, one of them is a number. All right. And then the third type, we'll make this red, that's by volume, which is always 22.4 liters per 1 mole of the substance. Right, this one is awesome. It's kind of like the first one because that side doesn't change. It's always going to be the same no matter what substance we're working with. And then the other side is the question. So the other side is the number, and the other side is the x. So that's what the first one's talking about, is looking at those 3 things: number, mass, volume. All right. All right, number 45. Name the representative particle, whether it be atoms, molecules, or formula units of each substance. So the first one is oxygen. But remember, oxygen is diatomic when he's all by himself. So you could get tricked into this one and think it's an atom because it's just him by himself. But remember, it's O2. Because it's O2, then therefore it's a molecule. That one's kind of a tricky one. All the diatomic ones, when they're by themselves, they're a molecule. Any of the other elements on the periodic table, aluminum, iron, copper, those are all atoms because they are not diatomic. All right, second one, you've got sodium sulfide, which would happen to be Na2S. That's a metal and a nonmetal, so that means it's ionic. So because it's ionic, it's a formula unit. All right. Letter C is sulfur dioxide. That's SO2. Well, sulfur is a nonmetal, oxygen is a nonmetal, so therefore that's a molecular compound. So therefore it's a molecule. And the last one, we got potassium. Is potassium all by itself? Is he diatomic? Nope, he's not. So therefore, that one's an atom. All right. I know this is confusing, all right, but it's a piece of chemistry that you kind of need to be familiar with, all right, is being able to tell the difference on those. And if you notice, when I told you way back at the beginning of the course, I told you all this stuff builds. So what we're using right now is stuff that we used back when we named compounds. When we named things as atoms, and then we named them as ionic compounds, and then we named them as molecular compounds. So we're utilizing that in this chapter in order to identify which type of representative particles we have. All right, 46. How many hydrogen atoms are in the representative particle of each substance? So the first one, we got AlOH3. Well, notice that 3, what that 3 actually means is it's 3 hydrogens. So you have 3 of them. Second one, letter B, H2C2O4. Well, there's 2 hydrogens in there. And letter C was the big one, NH4, 2, HPO4. So you got the H4 times 2, that's 8 of them. Plus you got another hydrogen all by itself next to the P, so that makes it 9. Then we got the last one, C4H10O. Well, there's 10 H's in him. All right, 47. Which contains more molecules? Ooh, here's a tricky one. You got 1 mole of hydrogen peroxide, H2O2. You got 1 mole of C2H6, that's butane. And you got 1 mole of CO, that's carbon monoxide. Now remember, a molecule, right, is like eggs are to a dozen. Okay? So if all of these things are a mole, if they're all a mole, then that means they're all a dozen. They're all chemist dozen. That means they're all 12. They're all 6.02 times 10 to the 23rd. So if they're all 6.02 times 10 to the 23rd, then which one's got the most? All the same. They're all, because they're all 1 mole, they're all 6.02 times 10 to the 23rd. They're all the chemist dozen. So that's a trick question on that one, but they all contain the same number of molecules because we're looking at the whole units. All right, it'd be kind of like me asking, which one's got the most? You got a container of a dozen eggs, you got a dozen cans of pop, and you got a dozen cookies. Well, which one's got the most? They're all the same, aren't they? You got 12 eggs, you got 12 cans of pop, you got 12 cookies. Same number for each one, even though they're all different things, right? They're all the same number of each one. Now we go to number 48. Now it becomes tricky. It says, which one contains the most atoms? So now we're looking inside of it and going, oh, we got to look at how many pieces, parts are there inside of it. All right. So when we look at this one, we go with the first guy. We got a mole of H2O2. Well, that's got 4 pieces to it, 2 hydrogens, 2 oxygens. Right. Then we go to a mole of butane, which got 2 carbons and 6 hydrogens. Ooh, that one's got 8 pieces. And the last one is a mole, a dozen, of CO, which has 2 pieces. Well, which one of these is going to have the greatest number of atoms? We'll look at the first one had 4, the second one had 8, the third one had 2. So which one is it? It's the second one. He's got 8 total times all the number of mole or particles that there are. So it's the C2H6 because he's got the greatest number of atoms per piece, per representative particle. All right, number 49. Find the number of representative particles in each substance. Ooh, now we got to do some math. So I'm going to move you so that I can stand up and do this. So hold on, you're going for a ride. There we go. All right. So what we need to do, we're looking at representative particles on these guys. 49. The first one, we got 3.0 moles of SN, which is tin. So, because we're looking at representative particles, which one of these are we using over here? We're using the black one up here at the top. So we've got 6.02 times 10 to the 23rd. And this is going to be atoms of tin per 1 mole of tin. Then we go to the other side. I'll make this blue. And it says we don't have 1 mole, we have 3.00 moles of tin. And we want to know X atoms of tin. So from there we're going to cross multiply. I'm going to go X times 1 equals 6.02 times 10 to the 23rd times 3.00. So you multiply this out, type in your calculator 6.02 exponent 23. Remember, don't type in times 10. And then go times 3.00. And then hit enter or equals, and you'll end up with an answer of, and I'll look it up, 1.81 times 10 to the 24th, and that was atoms of tin. So there's the answer for the first one. Excuse me. Second one. Second one, we are looking at 0.400 moles of what stuff? Potassium chloride. We want to know how many representative particles. Well, first of all, this guy is metal and non-metal, so this would be formula units. So we got to get rid of this, and we are looking at, this would be formula units of KCl per mole of KCl. So again, that part's not going to change because it's like a dozen. Then we go to the other side, and well, we don't have a whole mole, we got 0.400 moles of KCl. And we want to find out X formula units. So cross multiply, X times 1 equals 6.02 times 10 to the 23rd times 0.400. So you type that in and press equals, and you're going to get 2.41 times 10 to the 23rd. And that's formula units of KCl. So there's our answer for that one. All right, now we're going to letter C. So let's erase some of this. Erase the top up here. We gotta erase this, erase that. All right, letter C. They gave us 7.50 moles of SO2, sulfur dioxide. It's a smelly substance. All right, so we're still using this one. This is sulfur dioxide. Oh, that's a molecule. So we're looking at molecules of SO2, and this is moles of SO2. So we go to the other side. Well, I don't have a mole. I got 7.50 moles of SO2, and we're going to try and find out X, number of molecules of it. Cross multiply. X times 1 equals 6.02 times 10 to the 23rd times 7.40. Multiply those guys out, and you should get 4.52 times 10 to the 24th, and that's going to be molecules of SO2. All right. One more. What time we at? Okay. Making sure I don't go over my time. I know this review paper is going to take a few videos, but all right. The last one, letter D. So this one they gave us 4.80 times 10 to the negative third. And that's moles of NaI. So what is this thing? Well, this is a metal and a non-metal, so that means it's a formula unit. So we're looking at formula unit of NaI, and this is NaI. So I go to the other side. Oh, they're talking moles. The moles are on the bottom, so it's 4.80 times 10 to the negative third moles of NaI. And we're trying to find out formula units of it. Let's cross multiply again. X times 1 equals 6.02 times 10 to the 23rd times the 4.80 times 10 to the negative third. Right, so you type all this stuff in. Remember, you don't type times 10. You're going to type exponent for that piece. So X is going to end up equaling 2.89 times 10 to the 21st. And that's formula units of NaI. So there's our answer on that one. All right. I asked you any questions, but you're going to have to email me questions if you got them. So, all right, well, that takes care of those ones. All right, let's go on to the next one. We'll see if we can get a couple of these done before I hit the end of my time. So number 50, we got to calculate the molar mass of these ones. So we got H3PO4. So all we're, oh, there goes my legs. Hold on. So this one, all we're doing is we're just doing the double question mark that's over here. We're only doing this piece. They didn't give us an X, so we need to find out. We just got to find out the molar mass of this. So from this guy, we're going to go 3 times the mass of hydrogen, which is 1. Plus, we got 1 phosphorus times his mass, I think it's 31. Yep, 31. Plus, we got 4 oxygens times his mass is 16. So we multiply these guys out and add them up. So this is 3 plus 31. Plus, that would be 64. So that's what? 98. So it's 98 grams of H3PO4 per 1 mole of H3PO4. So there's your answer on that one. All right, next one is N2O3. All right, from this guy, we're going to go, there's 2 nitrogens times 14 plus 3 oxygens times 16. Multiply this out, that's 28 plus 48. So that would be 16, would be 76, right? Yep. 76 grams of N2O3 per 1 mole of N2O3. All right, based on my time right now, I'm going to stop. We're going to go to part number 2. We'll see you in a bit.